Hello, hello. Welcome to a great, grand, glorious day of pre-calculus. Today we're going to be talking about the average rate of change and the difference quotient. Two ideas that have some similarities, and yeah, they've got some similarities. So go ahead and put away those distractions, pull out your notes, and here we go. So first things we're going to talk about is what is the average rate of change. So the average rate of change, so we got a nice little thing that's typed out there, states if A and B, where A is not equal to B, which means they're not the same thing, because they can't be the same thing or this whole thing doesn't work out. So A and B are different numbers in the domain of a function, y equals f of x. So that's usually how we talk about things being functions, especially if we want to graph them. So y is equal to f of x, where f of x is the function, which is some rule of things that we're doing to inputs. The average rate of change of f, which is the function's name, so it could be g or h or whatever the function name is, from A to B is described as, so we have average rate of change usually gets abbreviated. Let's try writing that a little cleaner, AROC. So the AROC, that's our abbreviation, is the change in y divided by the change in x. Those letters are called deltas. We'll come back and talk about them here in a second, which can also be written as, let's see, the change of y values. Well, that would be f of b minus f of a, because that's how my y values changed. And then my x values changed from b minus a, where, and again, we just need to make that distinction, where a does not equal b, because if a was equal to b, then this part right down here would be 0, because I'd have to be subtracting the same number from itself. So where a does not equal b. So real quick, just want to talk about these little guys here. This guy, his name is delta, and mathematicians, and especially applied mathematicians playing with physics, so especially physicists, use this to mean that it means change. So the delta of blah, 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 blah is the change of blah, 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 blah. So delta y means change of y, delta x means change in x. And that will come back to haunt you again. You'll see this again. Like, probably not in my class, but in calculus, you will see that again. So where f of b minus f of a over b minus a. Mrs. Norton, that formula right there looks suspiciously familiar. Oh, I'm glad you think so, because it used to look like, let's see, we've got some point x1, y1, and then we got some other point x2, y2, and then we did y2 minus y1 over x2 minus x1, and we called this formula slope. Oh my gosh, it's the same thing, because now my ordered pairs are a comma f of a, because that's my y value for that fun thing, and b comma f of b, and we're subtracting the y values, and then we're subtracting the x values. And this is AROC. So slope is something that can happen for a linear function. Average rate of change, I've got my little c over here. There we go. Average rate of change can happen on any function. So slope, this guy right here is restricted to linear functions. Whereas this guy over here, I can use on any function to find the average rate of change between two x values. So notice I'm not saying between 2 points, between two x values, because x's are my addresses, y's just happen to be the output at that particular address. So let's come on down and play with some stuff and things. So first thing we want to do is we want to play with a graph, right? So let's grab this guy. Come on, there we go. See, you don't need to be scared. There we go. All right, so we're playing with this graph, this beautiful, beautiful, beautiful graph. And so the first thing we're wanting to find is the interval, finding the average rate of the change over the interval 2, 5. Okay, so notice I'm not giving you a point, and I'm not putting parentheses on this. I'm putting square brackets because I want you to start at the 2, end at the 5, include those two things, and that's what we're going to be finding our average rate of change of. So order kind of the flow for stuff and things. So the first step we're going to do, we'll put this over here. First step is we're going to find f of a, and then we're going to find f of b, and then we're going to plug numbers into a AROC equation. And then 4, we're going to simplify. Yay, fractions. Everybody loves fractions. Woot. Okay, so coming over here, let's see, 2, where is 2? So 2 is here. So f of 2, that's the point that I'm looking at. So f of 2 is equal to negative 2. And then I need to find 5. 5 would be about here. So here's f of 5. And so f of 5 is equal to 3. Okay, so there's my two things. So now I need to plug stuff into my equation. So it is f of b minus f of a over b minus a. Mrs. Norton, how do you know which one's b and which one's a? In the great grand scheme of things, in like the mathematical rules, it doesn't really matter which one's a and which one's b. However, typically the interval goes a comma b. So this is my a and that's my b. So a is the first number, b is the second number on the interval. So here's my equation. So plugging my numbers in, f of b. So this is f of b, and no, this was f of a. And this was f of b. Right. So f of a is going to be negative 2 minus f of b minus f of a. Sorry about that, guys. And then b, which is 5, minus a. I keep wanting to flip it. All right. So then that's going to give me 5 on top and a 3 on the bottom. And that's how I want you to leave it. I like improper fractions. I do not want mixed numbers, which we 1 2/3. So we don't want to do that. Okay. And then b, so letter b, is I want to find the interval from the average rate of change from negative 2 to 4. So negative 2 to 4. So let's see. A equals negative 2. So f of a equals, that would be this point here. So that would be equal to 1. All right, and then b is 4. So f of 4 is right here. So that would be equal to 0. Okay, so now I go pluggy chuggy into my thing. And so I've got 0 minus 1 over 4 minus negative 2. So that's going to equal negative 1 over 6. Boom shakalaka. Not too bad. All right, so that's when we're dealing with a graph. Dealing with graphs are nice. But sometimes we're not given the graph. We're given instead the function rule. So let's look at what happens when we have a function rule. So letter C was f of x is equal to negative 2x squared plus 4. And I want to find the average rate of change on the interval 0 to 2. My process is still the same. I still need to find f of a. I still need to find f of b. I'm going to plug the numbers in, and then I'm going to simplify my fraction. That's still what we're going to do. We just have to do a little bit more work to get the thing. So that would give me, let's see, negative 2 times 0 plus 4, which is 0 plus 4. And you don't have to show all of these steps. I'm just trying to make it really, really clear what's going on and how we're getting there. So that's going to be negative 2 times 4 plus 4, because order of operations says do the exponent first, then do the multiplication, and then do the addition. So there's my stuff things. So this is my f of a, and this is f of b. So plugging things into the formula, I've got negative 4 minus 4 over 2 minus 0, which will give me negative 8 over 2, which does simplify down to negative 4. And there's my average rate of change. All right, I'll just keep going down. It's fun. Hey, go away. All right, sorry, that's not the TV. I can't just tap it with my hand. All right, g of x for part D, that looks like fun. G of x is equal to x cubed minus 4x plus 7 on the interval from negative 1 to 1. All right, so g of negative 1 cubed minus 4 times negative 1 plus 7. Just trick, remember that if you have a negative inside of exponents, the exponent can see it as well. So watch out for that. And that's going to be 10. And then if I go over and I do g of positive 1, it's going to be 1 cubed minus 4 times 1 plus 7. 1 minus 4 plus 7, that'd be 8 minus 4, which is 4. Okay, so I plugged in a positive number and a negative. The positive and negative of the same number did not get the same output, or even the opposite. So this is not an even or an odd function. All right. There we go. So then we want our average rate of change. So this is g of A, and this is g of B. Just helps me keep things straight, 'cause apparently I keep messing that up. So then I have 1 minus negative 1. So that'd be negative 6 over 2, which is negative 3. Boom shakalaka. All right, E. Ooh, yes, must do this one. This one is fun. So question E was asking if I have f of x is equal to x minus 4 over x. And I'm looking for the average rate of change from 2 to 8. So plugging numbers in, f of 2 equals 2 minus 4 over 2, negative 2 over 2, negative 1. And then f of 8 equals 8 minus 4 over 8. So 4 over 8. Oh no, a fraction, no! I have to put a fraction in a fraction. Oh no, if only someone had made me practice things like, what are those called? Complex fractions where there's, oh yeah, we did that. All right, yeah, it'll be fine. So f of A, f of B, and here we go. So we've got 2, no, f of B. So 1/2 minus negative 1 over 8 minus 2. There we go. So 1/2 plus 1 would be 3/2. And if you want to, you can kind of like take a mental note, like, oh, right, this would be 2 over 2 because I have to have a common denominator. So 1 minus negative 2 would be the same as 1 plus 2, which is 3 over 2. Right. And then this is over 8 minus 2, 6. Oh no, I've got a fraction over a fraction. It's a complex fraction. It's okay. This is really 6 over 1. So we simplify this by keep, change, flip. There we go. And that's going to give me the 3 and the 6 can simplify down. It's going to give me 1 over 4. If you want to go ahead, oh, I didn't flip. I didn't change it. Dot. There we go. You can also, if you want to like do more work steps, you can do 3 over 12, which is also going to simplify down to 1, 4. Either way you want to do that. All right, so that's that. And that is the average rate of change. Now, coming back up here, our last little thought is talking about this thing called a secant line between the 2 points. So if I go looking at letter A, I'm going to clear this off real quick. So letter A, grab a ruler, was finding the average rate of change from 2 to 5. So we can have this thing called a secant line. So if I draw a line from the point where it's on 2 and the point where it's like this, right? And that makes the ruler go away. This thing right here is the secant line on the interval -2 or from +2 to 8. And so the average rate of change is also known as the slope of the secant line. And the secant line is just connecting 2 dots and running through the function as you can see here. So that's that guy. And then we also have our other secant line, right? We had another one that went from -2 to +4. So -2, always fun to get these things right on the money. There we go. -2 to +4, like so. Shoobity. And there's the average, there's my secant line for this other one. This idea of secant lines will come up again to haunt you, definitely in calculus, because they talk about these secant lines and the function definition of a derivative and blah, 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 blah. It ties into this stuff again. We'll see the word secant again in this class when we talk about trigonometry, and it's kind of tied into this because all of it's kind of tied together, but you won't be able to see it at first. All right, so that's everything to do with average rate of change. So these are the secant lines, and the average rate of change is the slope of the secant line if I just connected the 2 spots on the graph. And that's a big idea. All right, so let's go over here. Blah, 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 blah. Come on, give me more space. Blah, 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 blah. There we go. Now I've got more space. Let's talk about our good friend, the difference quotient. Difference quotient. There we go. Good times. Okay, so the difference quotient so we've got a function of f at x. And so what is the difference quotient? The difference quotient is defined as f of x plus h minus f of x divided by h, where h does not equal 0. So that's the definition of the difference quotient. That's kind of what we're going for. So we want so this is our difference quotient of f at x, and glorious things happen in calculus with this. So we're making you practice doing this particular move with different functions, because when you get to calculus, the algebra part, so people will say again and again, the calculus is easy, the algebra is hard. So part of what I'm doing here is I'm trying to make you practice that algebra so you've seen it before, so hopefully it's not quite as sticky when you get to calculus with this stuff and things. So here's the process, right? Our first step is we need to find f of x. So let's see, find f of x plus h. And then my second step is I need to find negative, or the opposite of f of x, because it's really easy to lose track of that negative when we have like polynomial functions that we're playing with and other stuff things. The next thing we're going to do is we're going to set up our fraction. Set up fraction, right, for our little formula thing. Floop. And last but not least, we are going to simplify using all of those wonderful skills that we have for simplifying rationals. Now, what is the goal with all of this shenanigans that we're going through, and what are we trying to achieve? The goal, right? No, actually goal. How do we know when we're done simplifying? So sometimes we have to do weird things to meet this goal, and that's fine because this is the objective. The goal, get rid of the h in the denominator. For reasons that will be explained to you later, mainly in calculus, this thing right here is the thing that we need to get rid of. We want that to go away for reasons. It has to do with calculus, and this is pre-calculus, so we're going to practice that. So there's my kind of my process, my flow, what we're going to be doing as we're going along. So let's look at an example. So on your notes, your first example is we're going to find the difference quotient for the following functions. We have f of x is equal to 2x squared minus 3x. So that's the thing that we're trying to do. So step 1, find f of x plus h. So f of x plus h. So everywhere I see an x, I'm going to replace it with x plus h inside parentheses. Minus 3 times x. All right, now this part got a lot of you guys on the last test we took. We got x plus something and it's squared, and a lot of people think, oh, that's x squared plus h squared, and it's not. So if you're one of the people that made that particular mistake on the test, then go ahead and expand this out like so. Like actually show what the things are that we're trying to do. So then we've got 2, and let's see, x squared plus xh plus xh plus h squared minus, and then doop-a-doop, and minus 3x. Stop getting over there. Thank you. All right, and to cleaning up the inside of my parentheses first before multiplying that 2 in. Just order of operations. Clean things up before distribution. Plus 4xh plus 2h squared minus 3x. Oh, that's disgusting. All right, that's fine. It's fine. It's fine. It'll work out. It'll work out. Negative f of x is equal to negative, and then square bracket all of these guys, 2x squared minus 3x. Can't clean that up, so we're just going to distribute the negative in, like so. Don't forget that whole thing right there. Now I need to set up my fraction. Okay, so fraction is, come on, there we go. That shenanigans, that's my f of x plus h, right? It always does this. I don't know why it always does that. That bugs me. All right, setting up fraction. So we've got 2x x squared plus 4xh plus 2h squared minus 3x. Does this thing, they gave me a new version of OneNote that I'm supposed to be using. Curious if it still does the thing. It doesn't. Oh, this is not a good. I don't like this. I miss my old version of OneNote where I can change colors on things without having to erase the whole stinking thing. Anyway, sorry. Not relevant to the lesson. All right, so there's my f of x plus h. Next, I need my minus 2x squared plus 3x. Okay, and then that's all going to be over h. And now I need to simplify things. Okay, simplifying things. Okay, do I have any like terms to combine? So right here and right here, I have the negative and positive of the same thing, so those can go away. Floop, floop. And this is a minus 3x and a plus 3x, so those can go away. Nice, we like it when that happens. All right, so that gives me 4xh plus 2h squared over h. Ooh, nice. Factor the h out. We've got 4x plus 2h. Divide by h. And that's going to give me 4x plus 2h. Boom, shakalaka. Okay, not bad, not bad. We got our difference quotient. We got that guy set up, and we're good to go. We're golden. And that is it. We're done. And in calculus, you would do a little bit more with that, but we're not in calculus, so we're not going to do a little bit more with that. We're just going to move back over here. Nope. Here. Right. All right. So next question. All right. That was fun. G of x is equal to 4 over x. Ooh, this one's a rational function. Okay. So first step, find fg of x plus h, because it's not f anymore. So that'd be 4 over x plus h. Okay, I can't simplify that anymore. Negative g of x, or the opposite of g of x would be negative 4 over x. Okay, I can't simplify that anymore. So let's put these things in my form. 4 over x plus h minus 4 over x, and then this whole thing over h. Simplify! Miss Norton! Yeah, it's another one of those complex fractions. Yay! Complex fractions! Everybody loved those on the test. Okay, so for right now, we're going to just deal with the top half, right? Because that's what we do with complex fractions, is we focus on the top half. Okay, so we got 4 over x plus h minus 4x. So how do I subtract fractions? Because in order to simplify this, I need this to be all one big fraction. So we're going to multiply this by x plus h over x plus h. And then we're going to multiply this fraction over here by x over x. That gives them a common denominator. Okay, so that's going to give me 4x over x times x plus h minus 4 times x plus h over x times x plus h. Okay. All right, so continuing on, that gives me 4x minus 4h over x times x plus h. Probably should have done one more step for just like negative 4x minus 4 times x plus h, just to show that that negative 4 is getting distributed to both of those guys. So anyway, that's where that whole thing comes from. And I can simplify this one more time, because right here I've got that 4x and that negative 4x, so those guys can cancel out. And that's going to give me negative 4h over x times x plus h. Beautiful. Okay, so now let's take that and put it here, right? Because that's where I got it from. So we have negative 4h over x times x plus h, and that's really all over h. H can also be written as h over 1, so I've got a fraction divided by a fraction, so when I'm simplifying that, I keep the first fraction, 4h over x times x plus h, and then I'm going to multiply that by 1 over h, so then my h's cancel, and that leaves me with negative 4 over x times x plus h. Boom shakalaka. And that's it, we're done. But Miss Norton, there's still an h in the denominator. Yes, but it's not a single factor that's just h. It's in a factor of x plus h. and that's okay. It's that solo h that's all by himself. That's the h I want to get rid of. So that guy, he's in parentheses with the x. He's fine. We've achieved our goal, and we are done. Yay! Okay, let's go look at another example, because, these guys are fun. Yay, fun. Norton, this is not fun. Well, it is for me. Okay, so square root x. There we go. Because we got to look at all of the different function types, right? We have a polynomial, we've got the rationals, and we got the square rooties. And these are the kind of the three main things that we've played with, algebraically speaking, for solving functions and simplifying things. Technically, there's an absolute value in linears, but those are boring, so we'll just ignore those. All right, so h of x plus h. Mrs. Norton, that's confusing. Why is there, that's too many h's. Agreed. Now that I'm looking at that, that was an oops on my part. Oh well. Negative h of x is equal to negative square root x. And then we put all of the things on my nice, happy little formula, right? Make sure that looks like an h and not an n, because I will mix that up as I'm going along, over h. Okay, so creativity happens a lot here. And so there's lots of things you can't do. You can't just multiply them by like x over x or something like that. We can do that with fractions because that's technically multiplying by 1, and that's okay. And so I don't have a fraction on the top, like up here, to do something like that with. So that's not our move. So what was the weird thing that we did with square roots? When we were simplifying them. Oh, right. Oh, it's right there on the tip of my brain. Rationalizing the denominator. That's what we called it, where we had to get rid of the square root in the denominator. This time we're going to do something weird called rationalizing the numerator. And so what we're going to do is we're going to keep the square roots the same. This is x plus h, and this is square root x. And whatever I do to the bottom, I have to do to the top. But we're going to change this symbol right here in the middle between them, like so. So I've got x plus h minus square root x, and then the square root of x plus h plus square root x. And we're going to set this up. So I'm going to write the bottom first because that's the easiest part. We're going to have h, and then parentheses, x plus h plus square root x. Now remember, our goal is still the same thing. We're trying to get rid of this h. That other h that's inside the square root, he's fine. He can come along the ride. Don't care. Okay, so I've got to FOIL, right? First, outer, inner, last. So that's going to give me the square root of x plus h squared. Plus the square root of x times the square root of x plus h. Ms. Norton, how does that simplify? Just hold on a second. Well, we'll come back to simplifying that here in a minute. First, we're going to multiply things, and then we'll worry about simplifying things. Then we got negative square root x, square root of x plus h, plus, minus square root of x squared. Okay, so then continuing to simplify the top. Square root of x plus h, and then that thing's getting squared, and square roots. They cancel each other out. They're inverse operations of each other. So that just turns into x plus h. Beautiful. And then this guy over here, right here, I've got square root of x times square root of x plus h, square root of x times square root of x plus h. You might have these flopped order-wise on your paper. That's okay. And turns out I don't have to worry about trying to figure out how to simplify that because I've got a positive one and a negative one, and I can just cancel them. Beautiful. And then back over here, I've got minus, and then the square root and the squareds, they cancel each other out. And then all of that over this shenanigans, h square root of x plus h plus square root x. Boom. Okay, so continuing on with my simplification trick, I've got a positive x and a negative x, so those are going to cancel. And I'm going to have h over h times square root x plus h plus square root x. Turns out those h's can go away. Oh, beautiful. Beautiful, beautiful, beautiful. And we're left with 1 over square root x plus h plus square root x. And that is the difference quotient for the square root of x. Kind of bizarre and weird, not gonna lie. I agree. That is a little messed up, but that is how it goes. And so polynomial functions are the easiest ones. We like those. The rational ones get a little weird because we end up having to play with the multi-level fraction nonsense, and that can get kind of annoying. And then these guys, the radicals, oh, they're so much work, but they are what they are. Anyway, that would be that. Let me know if you have any questions, concerns, comments, or queries. Don't forget to fill out your video reflection. And happy mathing! Bye!